Well, I'd like to welcome everybody to start to the Lean Six Sigma Greenbelt demonstration class. Now, over the next hour, we'll cover what Lean Six Sigma is and provide a better understanding of the methodology as well as the value that it can provide not only to you personally, but of course to the organizations you're part of as well. And then certainly if you've got questions throughout, please feel free, just put it in the chat session. And we should have, some time at the end of the session as well for you to ask some questions. Just a little bit about myself. I've been working, quite a few years, and I've worked in, both the public and private sector, working with organizations from small to multinational, and environments that range from transactional to manufacturing, and certainly, different industries and across different businesses. And so I point that out for two reasons. Firstly, through the training, it helps to be able to describe and explain the methodology and the tools involved in Lean Six Sigma using examples that are relevant to the participants or the class members. And so, that's helpful. So I pointed out for that reason. The second is just to demonstrate the breadth of the ability of the methodology or the ability of Lean Six Sigma to be applied across industries, across businesses, across lots of different circumstances. And so on that note, it really is an industry-neutral methodology that's very effective regardless of what type of business or organization you're part of. Now, if you go to some social media sites, and you went to LinkedIn, for example, you'd find that about 40% of managers in top companies are Lean certified. You'll see that certified Lean Six Sigma professionals earn 40% more than their non-certified peers. And the majority of quality managers hold multiple certifications. Now, it stands to reason that because the methodology is all about solving critical issues for an organization, that when you empower somebody through the ability to make changes to their organization, when they've got leadership support, and they've got a skill set, the capability to take on those challenges and lead people as part of a team through a project that addresses and permanently resolves a critical issue for that business, that individual is going to be recognized. Not only have they driven value through the organization, as you can see, from Motorola to Ford and so on, but they've proven themselves as somebody that can really get things done. And so, one of the best things that I've personally found through my involvement in Lean Six Sigma over the years is that you're really able to tackle those critical, those big issues and key opportunities that an organization periodically faces and get things done. And that's exciting. It's fun to come to work each day knowing you're going to make a change, have a positive impact, not only on the organization, but on the people around you as well. And so you certainly will be recognized, noticed, and succeed as a result of that. Now, over the course of the training, we go through 6 different learning units. Now, the first learning unit is around providing an overview of Lean and Six Sigma. So a little bit about the history. How did Lean come about? How did Six Sigma come about? What are the methodologies? And what are some of the what's the historical context of each, so that you appreciate that there's been an evolution of sorts from using the methodology and incorporating the tools that we used within Lean Six Sigma to where we are today, where it's a mainstay as a continuous improvement approach for so many different businesses. We move in to define the measure, analyze, improve, and control phases of a project, because it is a project-based methodology. We tackle issues or challenges in an organization, and we put projects together to address those issues. And so you might have heard the phrase or the acronym DMAIC. And DMAIC is really just the acronym for Define, Measure, Analyze, Improve, and Control. It's easier to say, I suppose, than 5 separate words. But through any improvement initiative or any work that we do in an organization, we start out by defining what it is that we want to achieve. It's not a lone wolf activity. You put together a project team, you put subject matter experts around you to work on that issue. You're leading that team, so you're demonstrating and gaining leadership competence, but you're also putting a team of people around, so that helps ensure that you've got the right knowledge, process knowledge, you've got the right set of people to help. It's not all one person having to do everything. You can delegate and so on. And maybe most importantly, you get buy-in from the subject matter experts because they're part of the solution. They're part of the team of people that are going to be figuring this out. And so in the define phase, you select your team members. You put a project charter together that says, here's the objective of what we're going to be working on. If we're successful, this is what we'll achieve. These are maybe some of the resources we anticipate needing for this project. Here's the timeline that we're, thinking that this will take, and so on. So those parameters create the foundation for your project, and it also ensures that everybody's aligned and on the same page and knows that what they're working on. As you move into the measure phase, here's where we talk about the tools or the strategies that we can employ to measure and understand our current state. Where are we today as we start this? It takes the blinders off. There's no fooling ourselves, thinking things are maybe better than they really are or worse than they really are. It's about taking stock of what the reality is for our current situation. And so we use a variety of tools or strategies to accomplish that. We make sure whatever information or data that we're using can be relied upon. Just because we run a report or a computer generates a report for us to look at doesn't mean that the information is correct. We have to validate it. Make sure that whatever critical information we're using and making decisions upon can be trusted. As we move through the measure phase, using the tools or strategies to create that current state understanding, we move into the analyze phase because the reality is this, that we only have limited resources. We only have so much time, so much money, so much energy, so much whatever's important to us. It's limited. We want to make sure that we invest it in the right ways, in the right places, at the right time, and so on. And so because of that, we go through the analyze phase to identify those critical elements of our process that we're trying to improve. Whether we're trying to improve a financial part of the business, whether we're trying to improve a customer-related part of the business, an employee-related, and so on. And so it's important for us to be able to understand those critical elements so that we can invest our resources wisely, because not every element or every component or every piece of that area of the business is going to be equally important. And so if we can invest our resources in the right places in the right way at the right time, we're going to get the best return on that investment. And so the analyze phase is about using tests. Quite often we use a lot of statistical tools in this area, and we teach them, of course, through the training so they become much more intuitive, that you can make that determination. And as we've identified those critical elements where we're going to invest our resources, we move into the improve phase. And in the improve phase, this is about using tools to identify, to test, to maybe experiment, to figure out what are the best ways to go about improving those critical elements. We might pilot something, we might use brainstorming, we might use design of experiments, we might use root cause analysis, and so on, to be able to figure out what's the best way to not only identify those improvements, but also the most effective way to implement them successfully. As we've done that, we move into the control phase because we want to make sure that whatever we've done is sustainable. It doesn't help us if we make a quick improvement and then everybody celebrates and it goes back to afterwards to the old way of doing things. That's not what this is about. This is about permanently changing things for the better. And so it's important for us to be able to use tools or strategies to make sure that the improvements we've generated are sustainable in the long term. And so we can use statistical process control charts, or SPC charts for short. We can use control plans and so on. And so through those 5 phases, the define, the measure, the analyze, the improve, and control phases, we build upon that foundation or that understanding of what Lean and Six Sigma are all about that we learned at the outset of the training program to truly understand how we can improve the business in the long term across those areas that will deliver the best return. So let's talk a little bit about Lean Six Sigma. Just from the short discussion we've had so far, it should become somewhat evident that it's a disciplined process. It's not about using intuition or best guesses. It's about using information, or sometimes what we can say data. Data is information. Using data to make better decisions. It's a much more robust, much more disciplined way about about doing things. It's also about continuous improvement. Each day we want to get better than we were the day the day before. And so we don't necessarily have to make these gigantic leaps, every single day, but those incremental improvements over time add up significantly. And so every day we get better and better. And Lean Six Sigma can help accelerate the pace of that improvement. Certainly when you instill and provide seamless training and resources to people, you instill that capability in your people, and you empower them to make changes across those areas of the business that need it and will benefit the most. That's very powerful. And in order for that to be successful, of course, you have to have consistent top management support. And so when the leader of an organization says, look, the way we're going to make improvement across critical areas, those key issues and challenges that we face, is through a more standardized, more systematic, more robust approach, Lean Six Sigma, then that sends a message. And so you need to be able to empower your employees, you need to have that with the capability, and you need to have them supported. Now I want you to think about for a moment a scenario from two perspectives. The first perspective is this. Let's pretend that you own a restaurant. And you can imagine as the owner of a restaurant, you work long hours. You probably work 6 or even 7 days a week as the owner. You probably work long hours, mornings, you might work nights as well. You don't get a lot of time for vacation. Now the good news is that you happen to be a member of a local trade association or chamber of commerce or some type of group that has a contest, and you win the contest and you have a 2-week vacation. It's been a long time since you've had a vacation. And so as you can imagine, most employees when they take their vacation, they're pretty happy, but in the back of their mind they're wondering about work. And so as the owner of this restaurant, you're going to phone the manager left in charge and ask them for some information because you'd like to know how the restaurant's doing in your absence. What kind of questions do you think you might ask? Well, I think that as an owner of a restaurant, I would probably ask about food sales. I might ask about beverage sales or liquor sales. I might ask about dessert sales, appetizer sales. I might ask about any employee issues or any equipment issues. Just like any manager, any owner, any business leader will want to know how the business is doing across different areas, they probably have a series of metrics. Maybe it's on a balanced scorecard or some kind of a dashboard, but they're usually metrics or measures that that manager, that business leader will want to know to gauge how well the business is performing. There's often a financial or a series of financial metrics. Maybe it's profit, net profit, gross profit. Maybe it's sales revenue. Maybe it's something else. But there are usually some financial metrics, just like there might be customer-related metrics and employee metrics and so on. Well, the reality is this, that they're really outputs, they're effects. In an equation, we could say that there are Y. They're the result of other things. They're a byproduct of the activities being performed across the business and how well those activities are being performed. Now let's look at that restaurant from a different scenario. And let's pretend instead of being the manager or the owner, we're a customer. As you can imagine, a customer probably has a choice of a large variety of restaurants, different styles of food, different price points, different types of ambiance. Customer might be interested in the speed of service. Are they there for a long leisurely dinner? Are they on a work lunch? What's the presentation of the food like? What's the quality of the service like? Lots of different things a customer might be interested in and consider when determining which restaurant to select. Well, those are the inputs. They're the causes. They're the things that drive the sales, the customer satisfaction, the employee productivity, the employee engagement, and so on. The results or the effects, those Y's, are really a function of those inputs or those causes. And the better we understand and can identify and manage those inputs, those X's, the better we can determine what our Y will be. And so Lean Six Sigma is about solving this equation. Wherever we've got a metric or a measure within our business that's really struggling or isn't where it needs to be or could be or we believe it should be, if we can understand what those drivers are for that metric, those X's, we'll say, the causes, then we can focus our efforts on improving those X's by being more surgical in terms of our improvement approach. And our Y will take care of itself. too often we throw things at that Y without necessarily understanding what those X's are. And very often when we've got a process or an area of our business that's struggling or suffering or not performing as well as it needs to, it's because we don't really understand what those X's are at all, or we misunderstand what they might be. And so when we solve this equation, we understand what the drivers are, the causes, the inputs to our critical processes, and we focus on those most critical X's, then our Y becomes better, and we see better results. And when we work on a project to identify those X's, we, as I started the presentation talking about, typically work through this DMAIC, or Define, Measure, Analyze, Improve, Control project approach. And they're really phases of a project. So, we start by defining the problem, the statement. We might say we want to improve productivity from where we believe we are today to some improved level tomorrow or at the end of the project. Maybe it's improving customer satisfaction from where we are today to somewhere else. Maybe it's improving something else. So we define our terms. We determine who's going to be involved in the project, who makes sense to have on the project team. We think this will take so much time, and so on. So we set the foundation, we align our goals, we all understand what we're working towards, and so on. We collect data as we move into the measure phase to understand, what the current state really is. We create a process map to understand the elements and the steps, the pieces of our project. We determine through the analyze phase which are the most critical elements of that process. Once we've done that, we can identify, prioritize, test the improvements, and we set up a control plan towards the end to make sure that going forward our improvements will be sustained. Because the project team that we're working with isn't a permanent fixture. It's probably a group of 4, 5, 6, 8 people that will work on this project until we've achieved some goal, and then it disbands. And so it's important for this team to leave behind this legacy saying, here's a more robust way, here's a control plan, we'll say, to make sure that the people involved in this process know how to manage it effectively so that the gains that we've been able to achieve through this project are sustained and perhaps even continue to be improved upon. Now, it stands to reason, of course, that the team members are often people that are involved in that process in any event, and so they'll be involved going forward. Just maybe not in a more formal sense that, we had a project team before and they were focused on this effort, and then, you move on and you go back to, your regular roles, but the elements of that process control plan stay in place, and so the new normal, the new way of doing things is much more clearly laid out for you. Now, as we go through those different phases, the define, measure, analyze, improve, control phases, and we talk about tools or strategies, this is a small sample of some of those tools or strategies. And so as an example, SIPOC is just an acronym, stands for Supplier Input, Process Output, and Customer. And it's a way of visually mapping out the steps of a process. And when we map out those steps of a process, we look at each element of the process, who's the supplier, or what's the supplier for that element? What's the input? What's the process step? What's the output or the result? And who's the customer for that element? It's a very good visual that helps also scope the project from its starting point to its ending point, because you want to make sure that everybody understands the things that are happening today. And very often what will happen is you'll have multiple people on the team saying, gosh, I didn't know that's what happened after my involvement, or I didn't know what happened before my involvement. When you start having those conversations, people can often identify some quick hit improvements, saying, well, gosh, if I had have known that, then I could have done this differently. And so that's often a very valuable exercise as you're starting your project. VOC, voice of the customer, CTQ is critical to quality tree, quality function deployment, and so on. So these are acronyms. And as we go through, of course, these will become much more familiar for you as we talk about them and teach you how to use them. Now, you'll notice that some of the tools are listed in multiple places, and it's because there's no set rule that says you must use an FMEA or failure modes and effects analysis tool only in the define phase. These tools were not designed for Lean Six Sigma. They were designed to solve specific problems, and very often they were developed or designed or invented within organizations and considered proprietary. They were trade secrets of sorts at, once upon a time. And so, because they were invented or designed to solve a specific problem or answer a specific question, if that problem or question happens at a different phase of the project and that's the right way to solve it, then you use the tool that's appropriate. Now, very often you'll use, the SIPOC map very early on in the project, just like, your voice of the customer. It makes sense to use it very early on so you understand what your customers want as soon as possible. You're not going to do your VOC at the end of the project when you might find, well, gosh, they wanted something completely different. You want to do it on the front end. So you make sure you align what you're doing with what your customers are looking for. Stands to reason. Now, Lean Six Sigma is going to be successful for the following reasons. When management supports Lean Six Sigma as a business strategy, it says, this is the way we're going to make important decisions. We're no longer going to rely on gut feel or intuition. We're going to use a more robust way to make important decisions. So we rely on information or data instead. It uses that DMAIC methodology for solving problems. That's a very logical, very straightforward, makes a lot of sense. Let's define what we're looking at. Let's measure where we're at today. Let's analyze to figure out what's important. Let's figure out what we're going to do about it, the improvements, and then let's make sure that we can control it going forward. Very straightforward, very logical, makes a lot of sense. And we, of course, incorporate the tools or the strategies within that framework or within that DMAIC methodology so that we can answer the questions we need to move forward. We have well-defined projects that directly impact the organization's bottom line. Now, I will expand on that by saying that what's really important is we work on those issues that are important to the organization. Very often, they have a financial component. Certainly, when you can argue that this project will deliver, this many dollars or this much money to the organization's bottom line, that becomes a compelling argument for the project. However, there are often times when an organization will take on a project because of some other reason. Maybe they're trying to mitigate some long-term risk. Maybe they're trying, here's an example, I worked with an organization that really wanted to be a good community citizen, really good corporate citizen. And they partnered with different charitable organizations in their community and periodically would do projects for them. Didn't necessarily help the business's bottom line, but they did it because they believed it was the right thing to do. Often, Lean Six Sigma will help increase customer satisfaction. In fact, I would say that virtually every project you do in some respect has an impact on your customer. And very often it also helps use statistical methods. So will require the extensive use of statistical methods. So for example, if we look at our measure at the beginning of a project and we say here's how well we were performing when we started, at the end of the project now here's how well we're performing after, we can run a test to determine whether or not that difference is likely to have happened by chance. And we would most instances find no, it isn't by chance. It's because of the improvements we put in place. But it's not just us saying, hey, things seem better, people seem happier, customers seem better, I think we're making more money. It's not a soft statement like that we're making. We're able to demonstrate through numbers saying that, yes, we've made a meaningful change to the business. Now, some key terms that we would want to look at and talk about as we move forward. Now, we keep saying the word or the words Lean Six Sigma. Now, you might be wondering, well, what is a sigma? Well, a sigma is another way to say the standard deviation of a process metric or a measure. Now, you can imagine if we have some type of a measure in our business, and maybe it's profitability, maybe it's customer satisfaction, maybe it's employee productivity. Whatever that measure is, we don't simply take one measure at one period of time and move on with it. We probably take it over a period of time, and there's probably some variation. Not every customer gives you exactly the same customer satisfaction score. Not every transaction delivers exactly the same amount of profitability, and so on. So there's some variation. Well, standard deviation is the average amount of variation about the mean, or the average. Mean's another way to say average. And so we can look at a process and the variation across that process over time, and we can measure that. And we know in a normal bell-shaped distribution that if we were to take a look at that over, let's say, I'll make up 6 months or a year, it could be any amount of time, that about 68% of all the results will fall within one standard deviation. About 95 will fall within 2, 99 will fall within 3, and so on, all the way up to 6 sigma. Well, with 6 sigmas of variation, 6 standard deviations of variation, it's going to capture about 99.99966% of all expected values. Now, when we can ensure that a process is delivering within customer expectations or customer specifications at the 6 sigma level, what we're really saying is that if my customer wants this product, this service, this whatever, and here are their parameters and how they want it, and we can consistently deliver that 99.99966% of the time, 6 sigma, then that's how good we are. And so we want to be able to deliver flawless performance. Now, when we look at an opportunity, it's really just you either do it right or you do it wrong relative to customer expectations. And when you do it wrong, we call it a defect. A defect, another way to say this, is that when you fall either on the lower side or the upper side of customer specifications, it's a defect. Now, to put this in plain language, if I go into my local Starbucks and I order a cup of coffee, I like my coffee to be a certain temperature, and so the company might say that, and I'm going to make up some numbers here, if that cup of coffee, and it could be tea, it could be whatever, is within 60 to 70 degrees Celsius, that's just the right temperature. If it's less than 60, it's too cold. If it's more than 70, it's going to be too hot. So my spec limits might be within 60 to 70 degrees Celsius. Anything outside of that is a defect. Our goal, of course, is to consistently make that cup of coffee within spec. It's up to the customer to tell us what those specs are. If they can't tell us, we need to figure it out, because that's what will make them happy. I might not be able to say that I want to be able to get in and out of a drive-through in less than 3 minutes, but the business might be able to run a test and figure out that, hey, our customers, as long as they get in and out of a drive-through in under 3 minutes, they give us really high recommend scores. When it takes longer than 3 minutes, the scores go down dramatically. And so sometimes a business will have to go out and figure out what their customers want. What is that voice of the customer? And then be able to figure out how to deliver that consistently. Now, very often what happens is that an organization will have, a process in place, and each individual within that process will think that they're performing pretty well. In fact, I've gone into groups where I've asked people to put up their hand if you think 90% is good. And most of the time, almost everybody puts up their hand. Well, you can imagine that if you've got a 3-step process, which would be pretty simple, pretty straightforward process, 3 steps and you're done. Well, let's say at the very beginning of the process, I give you 100 units. First person does their thing and 90% are good, so 10 are scrapped or have to be reworked, but 90% get to move on. And they're pretty happy, they're 90% good. Well, the second person now gets that 90%, and they're 90% good, so 90% of that 90% gets passed to the third person. That's 81%. The starting point for that third person is only 81%, and they're doing 90% of that. It goes down even further. When you've got multiple people involved at each step of the process, you get more and more waste involved, and that becomes very expensive. Not only does it cost a lot in terms of scrapped or reworked product or services, customers don't get what they want, they have to pay more, presumably, because the company is not as efficient or as effective as they are, and they're either absorbing the costs or passing them on through higher prices. Customers may have to wait longer. It's got to be frustrating for the employees. It's a bad deal. And so roll throughput yield is one way to look at that expressed as a percentage. It's a way to look at process efficiency expressed as a percentage. Now, I mentioned earlier on that at the 6 sigma level, we're 99.9996% good. Well, another way to look at that is defects per million opportunity. At the 6 sigma level, we'd only produce about 3.4 defects. Now, that sounds really good. In fact, if I said I was 99.379% good, most people would be pretty happy with that. In fact, I think most people would be pretty excited. They'd be putting up banners that, hey, I'm 99.379%. But for every million opportunities for a defect, they'd produce 6,200. Anybody want to get on a plane that's at 4 sigma? I don't think so. There are some processes, there are some things that organizations do that are so critical that you simply can't afford to be anything but flawless. Now, if I'm manufacturing, something that, I'm serving popcorn or something that's much less critical, then maybe I can afford to be a little more cavalier with that. But we have to look at our organization and say, for those critical processes, how good do we have to be? And this is the way we go about getting to be that good. And when you can implement Lean Six Sigma and you can put it into place, some of the benefits, they're so widespread. When you eliminate the root causes of problems and defects in a process, you create robust products and services, you reduce process variation, you're going to, achieve all kinds of benefits for your organization. You help ensure customer satisfaction. You can reduce rework by getting it right the first time. Imagine what that does to employee engagement, morale. When you set your employees up for success and they go in each day, they have a better day. And because they have a better day, you have lower turnover. You have happier customers. You have lower costs. It's a win-win-win for everybody. And you can see that the benefits aren't necessarily strictly financial or strictly customer-driven or strictly about employees. They go hand in hand. When one benefits, they all seem to benefit. They all seem to work in conjunction that way. I've never talked to someone that said, I went home at the end of the day yesterday because I had, had such a hard day, I was just too productive. You just don't hear people say that. You hear them say instead that I went home at the end of the day and I said to my family that I had a hard day, and then they talk about the problems or the obstacles that got in their way. Well, when we can remove those obstacles, those problems, we can enable people to be productive. They have better days. You have higher morale, better engagement. They're happier. Customers are getting what they paid for as well. And the company's incurring lower waste and expense because you have all those benefits as well. Now, the history of Lean Six Sigma is interesting because I mentioned earlier on that none of these tools or strategies that we talk about were developed or invented for Lean Six Sigma. In fact, the methodology really came about back in the 1980s when a reliability engineer by the name of Bill Smith, working with Mikkel Harry at Motorola, put together the program because they wanted to get from where they were, where a lot of their products were defective and they were having a lot of challenges and issues. Their competitors were simply getting better than they were. And they developed this methodology. Now, coincidentally, some of the members on Smith's team happen to be karate enthusiasts. They recognized the similarity between the discipline that they were looking at employing through the Six Sigma thing that they were talking about with karate, and so they called themselves belts, hence, green belts and black belts. That's where it came from. Now, Motorola went on to win the Malcolm Baldrige Award in 1986, the inaugural award. Malcolm Baldrige was a Secretary of Commerce at one time in the United States and a big proponent of quality. And after his death, they named this very prestigious award in his honor. And Motorola was the inaugural winner. And because of that, word started to get out and people started saying, hey, what are you guys doing? And people started talking about this Six Sigma. Jack Welch at GE got on board sometime in the 1990s. Allied Signal got on board. Today, the vast majority of Fortune 500 companies use Lean Six Sigma. You see a proliferation across, smaller and smaller organizations as well happening. So small and medium enterprises are adopting it. I've certainly seen a number of cities and municipalities and government agencies adopt Lean Six Sigma. It's a very powerful, industry-neutral methodology that enables an organization to transform itself from the old way of thinking, let's rely on gut feel or intuition or, whoever is the most authority gets to make the decision, to instead relying upon data. Let's use the information to guide us to make our critical decisions. And when you do that, it changes the nature of the way an organization operates and functions and thinks about solving its problems. And as some of these, examples on the slide that you can see, the savings are incredible. You're seeing these organizations saving millions and in some cases billions of dollars because they're driving waste and inefficiency out of their system. Now, there's no one single model that says this is the only way you can implement a Lean Six Sigma team. However, this is a very good overview of what most successful organizations look like. Now, whether they call these roles by these names can vary, but essentially they function as outlined here. So, you'll have top executives that will lead the change and provide direction. They ultimately own the Lean Six Sigma initiatives, because if they're saying, our goals for the organization are, here's around profitability, here is around, customer satisfaction, want to be the first choice of customers, here's around, employees, and so on, then they know where they need to focus their efforts. And so they can say, we need to improve in these areas. They have that broad oversight and visibility to not only where they are today, but that longer term vision, so they can align the two. You'll have Six Sigma champions. They'll help identify and scope projects. They may be, they may not be C-suite executives, but they might be vice presidents or senior leaders that will help identify as well the projects that will be worked on. They have that visibility as well. They're connected that way. You'll have Six Sigma Master Black Belts. They're the functional leaders of the organization. They'll train other functional leaders as well. They'll train and coach black belts and green belts. They're the technical experts in Lean Six Sigma. They may also take on some broadly scoped projects or strategic projects in nature. And then you'll have both green belts and black belts. Now, black belts and green belts in some organizations will be determined in terms of the time they spend on projects as well as the scope and complexity of those projects. So a black belt, for example, might be a full-time resource. That's what they do every day. They work on Lean Six Sigma. And they can work on Lean Six Sigma across the business. It's a very, very good leadership development approach as well. When you take some of your best employees, you train them in Lean Six Sigma, and then you let them work on projects across the business, that's extremely powerful as a development strategy. Green belts tend to work on projects that aren't necessarily as complex or broadly scoped as black belts. They may or may not be full-time resources. So, for example, they may say, well, gosh, I work in HR or IT or operations or finance or engineering or wherever, and I want to work on projects within my area of the business. And so they'll work on it more on a part-time basis. So some percentage of their time might be devoted to improvement work. Now, of course, it varies from organization to organization how they define, green belts and black belts and so on. But this is a very common framework. Now let's talk about an example of one of the lessons that we would talk about. And this one comes from Overview of Lean Six Sigma. So at the outset of the training, the first day, for example, we would talk about this. And topic number 3 happens to be about Design for Six Sigma. Now, Design for Six Sigma, or DFSS for short, and I guess DFSS is a lot easier to say, it's not quite the same mouthful. When we've got one of two situations happening, Design for Six Sigma is really the approach that we take. When we've got a process or a product that is too badly broken to merely fix, it needs to be instead redesigned or a new one developed, invented of sorts, then DFSS is a very good approach. Alternatively, if we are trying to create to an existing product line or service, then we might use DFSS as well. One of the tools within the DFSS framework is the Failure Modes and Effects Analysis, or the FMEA for short. Now, the FMEA is a very good preemptive tool that helps identify potential ways a process might fail. Now, when we work through the FMEA, we're going to calculate something called a risk priority number. And it's simply a measure of risk that we can assess that would be associated with that design or that process. And the risk priority number is the result of looking at a potential failure, and that potential failure has been looked at through 3 different lenses. The first is the occurrence. How frequently does it occur? Severity, how bad would it be if it did occur? And detectability. What is the strength of our detection mechanism to stop that failure from happening in the first place? And so when we look at each element of a process and we say to ourselves, or our team rather, how frequently do we think this occurs? How bad would it be? What's the detection? We score those on a scale of 1 to 10, 10 being the worst, the most severe, the most frequently occurring, and so on. Multiply those scores by each other, we get that risk priority number. Now we can use the FMEA on either a new process that we're designing or an existing process for that matter. It might look something like this, where we'd say, what's the process step? What's the key process input? In what ways does the key process input go wrong? What's the impact on the output variable, the customer requirements? How is the customer impacted if this fails? How severe would that effect be on the customer? What causes the key input to go wrong? How often does it occur? What are the existing controls and procedures that might prevent the cause or the failure from happening? And how well can you how well can you detect or prevent that failure mode from happening? And then when you take the severity on a scale of 1 to 10, occurrence and detection, you multiply, you get that risk priority number. Now, there are scales that we can use. And I would suggest that you can certainly use this exact scale in the language that's used here, or you could go through your project team and calibrate them and say, well, look, with 10 being the worst on a scale of 1 to 10 for severity, how would we want to word that? And maybe it's catastrophic. Maybe it's, something else. It's important to make sure that everybody on the team that's going to go through and use this rating understands what the language means. And if hazardous without warning makes perfect sense to you, then that's great, use this language. But again, if it doesn't, then what would a 10 be in your world? What would a 9 be in your world? And so on. For occurrence, similarly, we've got a scale here, same thing, in terms of does this language, do these numbers make sense for you? And our detection score. Absolute uncertainty, there's nothing in place at all today. Very remote, there's a very remote chance the design or the process control would detect potential cause or mechanism of subsequent failure mode. There's really very little in place that would prevent it. Remote and so on. And so here we have an example, and let's pretend that we're a bank manager. And as a manager of that bank, we recognize that very often we compete on our rates, and we're saying, well, gosh, that's a pretty tough way to do business. And so what we're going to do is we're going to make sure that we provide great customer service. We want to make sure that our customers can depend on us. And so let's look through the customer satisfaction scores over the last period of time, let's say 6 months, and look at the different things that customers have said about us so that we can identify those areas of the business we need to improve the most. We've done that, and one of the top items happened to be when people take out money or cash withdrawal from the ATM, the customer's account's debited but cash is not paid. In other words, you see the slip that your balance has been reduced by whatever you tried to take out, but didn't dispense any cash for you. So you're going to be pretty unhappy, extremely unhappy even. In fact, on a scale of 1 to 10, you might say, gosh, that's a 9. You might say, as the project team, well, what are potential ways that this could, happen? Well, maybe there's non-availability of cash in the ATM. Machine ran out of cash. Maybe there was a network issue. It thinks you gave the cash, but it didn't. How often does it occur? Well, the team believes, based on their research or their experience, their training, that on a scale of 1 to 10, the first one's a 7, the second one's a 5. Now, just break at this point to mention that we haven't gone out and validated the data yet. This is a tool we tend to use early on in a project because we probably have quite a large number of customer complaints. We want to filter down to the ones that are most critical for us before we go out and start collecting hard data and measuring and actually testing and so on, because that'd be potentially it's time consuming. And so this is a preemptive tool in that sense. It gets us very close to those issues that are most important, and so we're still using and relying on the subject matter experts on our project team at this point before we actually start going out and measuring and collecting data. In any event, going back to the FMEA, we've taken those severity, occurrence, and detection scores, we've multiplied them by each other, and we've gotten 112 and 405 respectively. And I will say that I see that current design control has been given none, and they score that a 9. I'd personally give it a 10 because if you've got nothing in place, it doesn't get any worse than that. So it's a judgment call, but this team gave it a 9. Now, as a project team, you'll probably put together some recommended actions, which they've done. You might assign responsibility and target completion dates. They've left that a little bit vague. Now, we'll come back to this at the end of the project and we'll rescore this because the project was about identifying those critical areas. Let's pretend that we went out and we verified that, yes, in fact, This is happening a lot. You know, it's not just that we hear about it because those customers that this happens to are the loudest. These issues really do happen a lot, and they need to be addressed, and so we've addressed them. We've put improvements in place, and we have come back to the FMEA to rescore, to test to see how effective our improvements are. Now, the team has said, well, gosh, if this happens, it's still a 9. The difference after the improvements have been put in place at the end of the project is that they're really not happening very often at all. We've gone from occurrence of 7 down to a 4 and from a 5 down to a 2. It's because our detection mechanisms are far more robust. They're much better. In fact, we've gone from a 7 to a 1 and a 5 to a 3. And so our risk priority numbers have decreased tremendously as well, from a 112 to a 32 and from a 405 to a 54. So we've revisited this and we've said, okay, based on the improvements we've put in place, they've been very effective and we've been able to improve the business as a result, and customers are much happier with us as a result of this as well. Now, this is just one small example of a tool that we talk about in Lean Six Sigma, and we would certainly go through it in more detail. We've got, you know, the template for you that we would work through as well, so you'd gain an even better understanding of how to use this tool and in what situations and circumstances it could benefit you. Now, we do that through, you know, more than 57 hours of training in Lean Six Sigma. We talk through different industry case studies and, you know, more than 100 real-world examples. You can attend batches, you know, on weekends or weekdays or, you know, whatever makes sense for your schedule. There's on-demand support with dedicated team and Simplilearn community, so you can reach out and talk to others. There are guest lectures, and there's training by industry experts, people that have done this and used the methodology in the real world and can talk about their experiences. Now, here are some of the upcoming batch dates. As you can see, they, you know, are during the week and evenings and weekends as well. So whatever makes sense for your schedule, there's availability, so you can select a batch that makes sense for you. On that note, I see we have a few minutes left that I'll open it up for any questions that you might have. I think I can see your questions in the chat box if you have anything you'd like to ask. Alternatively, you can also send a note through to Simplilearn directly, or go to the Simplilearn community and query there. About the RPN being 126 instead of 112. Let me take a look. Just like 9 times 5 times 9 should be 405. I haven't done the math manually, but thank you for pointing that out. How do we get 32? Here, let me just minimize this so I can see. Yeah, we've gone back through this again. So, you know, we'll use the FMEA at 2 points in the project. We'll do it at the beginning or early on in the project so that we get a sense of, you know, we might have 25 or 30 elements of a process that we're looking at, some larger number. Well, that's a lot of stuff to go investigate and test. And so this FMEA is like a filtering tool where we can go through this with the subject matter experts. They say, you know, they'll come through and we'll calculate these initial RPNs. Some of them will be, you know, like 405 is pretty high. Some will be much lower. I don't know if 112 would be particularly high on most FMEAs, but we'll say it is this example. Well, we're not going to go investigate everything, nor are we going to address everything in this project because there may just be too much stuff there. And so we'll prioritize it based on the RPNs. Those RPNs the team believes are critical enough that we move forward with, we go and we collect data for. We validate what we thought was happening. We'd actually go measure this and test this to see if this is really happening. And if so, then we develop and implement improvements and we make sure that they work. And we come back and we visit the FMEA at the end to make sure that, you know, that they've had the desired impact. And so we would rescore it at that point. And so at the end of the project, after the improvements have been put in place, we'd say, well, if it happens, it's still just as bad because it, you know, it is. The difference is that it's not happening anymore. It used to happen a lot, and now because of the stuff we've done, it just doesn't happen very frequently. And so, you know, we've rescored it, and we get those lower scores. Yep, 9 times 7 times 2, that would be correct. Okay, so it sounds like there might be, there's some math errors in there, possible. Let me just minimize this. Now I'm going to very quickly go to the first couple of slides. Somebody came on. So as I'm talking about Lean a little bit, I talked about myself, of course. Lean and Six Sigma. Lean came about with the same goal that Six Sigma came about. at the end of the day, organizations, Lean was actually developed through Toyota Production System. They wouldn't call it Lean at Toyota, they'd call it TPS. Lean came about sometime in the 1980s or early 90s. There were some books written, Machine That Changed the World and Lean Thinking. James Womack, Daniel Roos, and some others that started talking about this lean way of thinking about an organization. And so, the Western world will refer to lean, but in Japan at Toyota, they just call it Toyota Production System. Their goal is to provide value for the customer. They recognize that a lot of the stuff they were doing was not necessarily value added. The customer didn't ask for it, they didn't want it, didn't transform the product or service in any way. Customer didn't want to pay for it, non-value added. They wanted to reduce or eliminate that as much as possible so that they could provide value for the customer. So they developed a series of strategies or tools around that. Now, Six Sigma, they wanted to provide flawless performance to their, to their customers. Six Sigma, 99.9996% of the time, you provide, what the customers want and what you said you would give to them. So they have the same goal. Now, the idea is to, and there's so much overlap because, one of the wastes within Lean is defects. Customers don't want to pay for defects. And so a lot of the Lean work and a lot of the Six Sigma work overlaps because it has the same goal, the same approach, the same outcomes being desired. The difference is just maybe they're different, some different tools. And so there was a blending of Lean and Six Sigma thinking some, maybe in the last 10 years or so. So instead of having this Lean track or the Six Sigma track, you have more of a blended approach where you've got Lean Six Sigma. And you use the tools or strategies that make sense to solve the issue, your problem that you've got in front of you. So I don't know that I would separate them and say they're different things or they are, flipping slides here, I shouldn't do that. They're just different approaches. I would certainly recommend as well that, do some research on your own in terms of Lean and Six Sigma. It's maybe a little bit more detailed of a conversation that we can have within a couple of minutes here, but reach out to Simplilearn as well, and we can address that offline. You can get a copy of this PowerPoint through Simplilearn. Now I have on the hour, so our hour is up. So on that note, I'm going to have to say goodbye, but thank you very much for attending. I hope you enjoyed the session, and we'll appreciate your feedback. On that note, thank you again.